In this video, we're going to review the basics of the trigonometric ratios. Now, trig ratios use this very helpful acronym called SOHCAHTOA. As you can see in the big colorful letters, SOHCAHTOA has a lot of letters going on. You got SOHCAHTOA, and it's written in kind of a weird way, but there's a reason for that. So, looking at SOHCAHTOA, the first three letters I'm going to focus on are the S, C, and T, the big letters, right? You have S, which will stand for sine, C, which will stand for cosine, and T, which will stand for tangent. Okay. Now we have abbreviations for these, which you can kind of see on the right side over here. Sine will abbreviate as SIN. It looks like sin, but we pronounce it sine. Cosine, we're going to abbreviate as COS. And then you got your tangent, TAN. Okay, so that's that part. Those are the ratios. Those aren't going to ever change or be numbers. Like those are the three main parts of the trig ratios here: sine, cosine, tangent. Okay. Now the rest of these is what we're eventually going to fill in with numbers, with variables. Okay, and we're going to kind of solve for. All right, and that's what this O, A, and H are. Now you already know what these are from the previous video. These are the hypotenuse side, opposite side, and adjacent side. So O, A, and H is opposite, adjacent, hypotenuse. They are the sides of your right triangle. Okay. Now, the way it's written weird like this, all right, and these colorful letters up here is that, all right, that's the kind of order that we're going to write our ratio. So reminder, a ratio we're going to write as a fraction. You can represent ratios in different ways, but we're going to represent it as a fraction that compares two values. Okay. So when it says so in SOHCAHTOA, S-O-H, okay, the O up top and the H on the bottom is going to represent opposite over hypotenuse. Okay. The cosine is going to be A over H, which will be adjacent over hypotenuse, and your tangent is going to be O over A, opposite over adjacent. That order is important, which is why we have this acronym to help us. So the last thing we'll just kind of say before we move on to the examples is, if you look over at these mathematical definitions on the right side over here, okay, obviously there's a lot of letters and words going on. Okay, so where do like the numbers and what do we end up solving for? Where does that come into play? All right, now the sine, cosine, tan that I underlined here, that's going to, like I said, stay like that. But the part right next to it, the A, that part is going to be your angle. Okay, now A doesn't stand for angle here. It stands for maybe the name of an angle, angle A. Okay, but that's going to be your angle measure. And your O and your H, these sides over here, okay, these are going to be side lengths. Okay, so the side lengths of your different triangles. And that's eventually what we're going to start to plug in to solve these out. Okay, but right now we're just going to practice on, are we able to label these sides and then set up our ratios: opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Are we able to set up these ratios? And then that's going to help us solve these later in the module. Okay, so to summarize kind of this part here, and we're going to look at these examples using these ratios. All right, right triangles, okay, are going to follow the same ratio every single time. Now, obviously, we know that if we have a little itty bitty small right triangle and a very large right triangle, the side lengths are going to be different. But if the angle measures are the same, they should follow the same ratio. Okay, that's the idea here. So if you have all the sides of a triangle, they should follow the same ratio. You can actually find out what the angles are going to be if they're the same ratio. And if you have the angle and one side, you'll be able to find what the other side is using this ratio. And that's what we're going to do later in the module. Okay, so the skill that we're going to finish up with right here is we're going to set up the ratio of these triangles. Okay, of these triangles. So as you look here, all right, we're going to start with the left side. We have triangle A, B, and C. Okay, so the first skill we're going to do is what we just reviewed in the previous video, and that is labeling opposite, adjacent, and hypotenuse. So, for example, let's start with hypotenuse across from my right angle. That makes this 5 my hypotenuse. My reference angle, we're going to use this theta right here. And look, angle A is my reference angle. Okay, angle A is right here. That means that the opposite side is going to be this 3. So we have our opposite side right there. And that's going to leave this 4 over here as my adjacent side. Okay. Okay, now that we're looking at our three sides right here, this is where we're going to use this SOHCAHTOA up here. So if I want the sine of A, okay, the sine of A, I'm going to make a ratio. So I'm actually going to make kind of a fraction for all three of these to start. And we're going to set up our ratio here. So sine of A is going to be opposite over hypotenuse, right? So look, my opposite side. Now I can put over H, but then I'm just kind of recopying SOHCAHTOA. So let's actually use the side length. So 3 is my opposite side. Okay, look, 3 right here. There's my opposite side. I'm going to put a 3 there. And that means that my hypotenuse is going to be 5. So look, the sine of A follows the ratio 3/5. So I'm going to do the same thing for cosine. It's just this time I'm going to use A over H. Look at SOHCAHTOA, A over H. So my A is going to be 4. All right. I have adjacent over, and look, my hypotenuse is still 5. So I'm going to still put 5 there, 4/5. And so for my last one, tangent of A, okay, we have opposite over adjacent. So I'm going to put that opposite side 3, okay, over my adjacent side 4. And boom, I just found the 3 ratios for this problem. 3 over 5, 4 over 5, 3 over 4. Okay, so what I want to show you on the right side is, look, this is the exact same triangle, okay? But notice how we switched the reference angle from A to C. And look what this is going to do. It's a little interesting, okay? So as I go through and label my sides, I still have my hypotenuse side is 5. Okay, look, there's the hypotenuse. Now my opposite side is going to be 4 because we switched our reference angle. And now my adjacent side is going to be 3. So here's the thing. I'm still using SOHCAHTOA. I'm still going to use the same exact ratios that we've been using. But this time, okay, the numbers are slightly different. Now, the one that's not different is hypotenuse. So when we do sine of C, opposite over hypotenuse, this time my opposite is 4, right? Okay, and my hypotenuse is still 5. So look, sine of C is 4 over 5. Cosine of C is going to be adjacent, which is 3, over hypotenuse, which is 5. And for my last one, you have opposite over adjacent. So we're going to have a 4 over 3. And there's the ratios that I can set up. So SOHCAHTOA helps us set up our ratios using our opposite, adjacent, and hypotenuse sides. And the last thing I want to point out is, take a look. The main difference is when we switched our reference angle, the opposite and adjacent sides switched. So even though sine is still opposite over hypotenuse, look, the 3 and the 4, okay, kind of switch and traded places. Okay, so that's why identifying your reference angle is going to be very, very important when doing this.